Hello everyone, Ramya, Assistant Professor of CSE Department from Rohini College of Engineering and Technology, Subject Code CS 8591, Computer Networks, Unit 2, Topic Data Link Control. Data Link Control. Here the data link control functions including framing and flow and error control. Framing, data transmission in the physical layer means moving bits in the form of a signal from the source to the destination. The physical layer provides bit synchronization to ensure that the sender and receiver use the same bit duration and timing. Here the data link layer on the other hand needs to pack bits into frames so that each frame is distinguishable from another. Framing in the data link layer separates a message from one source to destination by adding a center address and a destination address. The destination address defines where the packet is to go. The center address helps the recipient acknowledge the recipient. Next, we are going to see the frame size. It can be fixed or variable size. In fixed size framing, there is no need for defining the boundary of the frame. The size itself can be used as a delimiter. In variable size framing, prevalent in local area networks. In variable size framing, we need a way to define the end of one frame and the beginning of the next. Next, we are going to see the character-oriented framing. That means it can be the data to be carried at 8-bit characters from a coding system such as ASCII. The header, which normally carries the source and the destination address and other control information, and the trailer, which carries error detection redundant bits. Next, we are going to see some diagram for the data link control. In that first diagram, it shows the in byte stuffing. A special byte is added to the data section of the frame when there is a character with the same pattern as the flag. The data section is stuffed with an extra byte. That means the byte is usually called the escape character and has a predefined bit pattern. Whenever the receiver encounters the escape character, it moves it from the data section and treats the next character as data, not as a delimiting flag. That means here it is the process of adding one extra byte whenever there is a flag or escape character in the text. Next, we are going to see the bit oriented framing. That means in addition to headers, we will still need a delimiter to separate one frame the other. Most protocols use a 8-bit pattern flag as the delimiter to define the beginning and end of the frame. That means this flag can create the same type of problem to prevent the pattern from looking like a flag. This strategy is called as a bit stuffing. It is the process of adding one extra 0 when 5 consecutive ones follow 0 in the data, and so that the receiver does not make the pattern for a flag. Next, we are going to see the flow and error control. One of the responsibilities of the data link control sublayer is flow and error control at the data link layer. Here the flow control, whenever an entity produces items and another entity consumes them, there should be a balance between production and consumption rates. If the items are produced faster than they can be consumed, the consumer can be overwhelmed and may need to discard sometimes. We need to prevent losing the data items at the consumer site. For that, flow control is needed. Here the flow control at this data link means at the sending node tries to push frames towards the data link layer at the receiving node. If the receiving node cannot process and deliver the packet to its network at the same rate that the frame arrive, it becomes overwhelmed with the frames. Next, we are going to see the buffers. That means although flow control can be implemented in several ways, one of the solution is normally to use two buffers, one at the starting data link layer and other at the receiving data link layer. A buffer is a set of memory locations that can hold packets at the center and receiver. The flow control communication can occur by sending signals from the consumer to the producer. When the buffer of the receiving data link layer is full, it informs the sending data the link layer to stop pushing the frames. Next, we are going to see the error control. We need to implement error control at the data link layer to prevent the receiving node from delivering corrupted packets to this network layer. There are two methods to implement the error control. The first method, if the frame is corrupted, it is silently discarded. If it is not corrupted, the packet is delivered to the network layer. This method is called mostly in wide LAN such as Ethernet. In the second method, if the frame is corrupted, it is silently discarded. If it is not corrupted, an acknowledgement is sent for the purpose of both flow and error control to the sender side. Next, combination of flow and error control. Flow and error control can be combined in a simple situation. The acknowledgement that is sent for flow control can also be used for error control to tell the sender the packet has arrived uncorrupted. Connectionless and connection oriented means here the data link control protocol can be either connectionless or connection oriented. Connectionless protocol. In a connectionless protocol, frames are sent from one node to the next without any relationship between the frame. Each frame is independent. Thank you.